We are going to study buoyancy. Then we are going to study the stability of submerged and floating bodies. Then we are going to study something called as the metacenter or the metacentric height, which is directly related to floating bodies. Okay, and then finally and then we'll conclude this lecture. So moving on to buoyancy. So buoyancy, before going to the definition of buoyancy, we should see something that we already know in horizontal direction and in vertical direction. Suppose we are considering a water surface level, and there is a body, inside the water, and we are considering 2 points, one at the horizontal level in the horizontal direction. So if I ask you, and let us consider a strip of area dA. So if I ask you if the height of the depth of point 1 from the water surface level is h1 and depth of point h2 from the water surface level is h2, then pressure on the point 1, that is p1, will be how much? Rho. Say density of fluid is what? Rho. So what will you say? That rho g h1 will be my pressure, and what will be the force on this strip, since the area is dA. So rho g h1 into dA, that will be the force in this direction going towards the right, and pressure in the p2 direction will be rho g h2. Similarly, force is rho g h2 into dA. We know from here, we can see that h1 is equal to h2, and the fluid is, if the fluid is static fluid, means it's not moving in any direction, then force 1 is equal to force 2, means there is no change in the horizontal direction. However, if we consider 2 points, say like in the vertical direction on the body, moving towards the right, say like this, so if the height is h1 for the point 1 and height is h2 for the point 2, then pressure, we know that pressure acts directly vertically, that is making an angle 90 degree. And let us consider a strip of area dA, then rho g h1, and from below there will be a pressure of rho g h2. And if I go for writing the force on the area d1, then f1 will be equal to rho g h1 into dA, and here f2 will be equal to what? Rho g h2 into dA. Since we can directly see that h2 is greater than h1, which implies that f2 will be greater than f1, which means what? Which means that there is a net upward force acting on the body, acting on the strip, since we have considered the strip of area dA strip. Now I need to calculate it for the whole body. So what will I do? So this net upward force is actually the buoyant force. So it is we are slowly moving towards the definition of buoyancy. So let us first calculate the small. So there is a net upward force. What will be the net upward force? The bigger force minus the smaller force. Bigger force minus the smaller force, and it will be in the upward direction. So what is the force? Is rho g h2 dA minus rho g h1 into dA. Taking the common terms out, rho g h2 minus h1 into dA, right? And we can say that this h2 minus h1 is, say, h, and h into dA, and this is what? This is nothing but the volume of the dV, that is the volume of the strip, of small strip, right? Then which means that rho g dV. If I want to calculate the total upward force on the body, we need to integrate it. Integrating total upward force, that is the buoyant force, integration of rho g dV. Again taking the it will be the volume of the body. But we should remember that total buoyant force that is in the upward direction will be how much? Rho is what? Rho is the not the density of the body, it is the density of the fluid, and g is acceleration due to gravity, and finally v is what? V is volume of what? Volume of the displaced fluid, or you can say the volume of the body also, since volume of the body and the volume of the displaced fluid will be same. Okay, so finally we come to the buoyant force, which is in the upward direction, that should be given as rho g and v displaced fluid. Okay, we know that we already know that if we multiply rho into v, we will get what? We will get mass, right? Mass, and then mass into g will be what? Will be weight. So we can also say that force of buoyancy is weight of the fluid displaced. If you are having trouble, I can do it again. Rho into g is what? Weight density gamma and volume displaced fluid. Gamma into v is what? Weight again. So the main thing you have to remember is that it has nothing to do with the density of the body, but it has everything to do with the density of the fluid. However, the volume of the displaced fluid will be of importance. Now we can come to the definition of buoyancy. So if I say it, what is buoyancy? So buoyancy, when a body is immersed in a fluid, so I would say not a fluid, in a static fluid. Okay, maybe no, in the running fluid also it is there. So an upward force is exerted by the fluid on the body. This upward force is equal to the weight of the fluid by the body and is called the buoyancy, or simple buoyancy, or thrust. It is also called as thrust. Okay, I have already derived, and it is the upward force in the vertical direction, and I have already derived that in horizontal direction for static fluids there is no force acting. Okay, Now, where this force, every time we study force, we should study where the force is acting. That brings us to the center of buoyancy. What is center of? So if you go by the definition of center of buoyancy is defined as a point through which the force of buoyancy, the upward force of buoyancy, is supposed to act. As the force of buoyancy is a vertical force and equal to the weight of the fluid displaced by the body, center of buoyancy is the center of gravity of the fluid displaced. Suppose this I'll give you two scenarios. Say like a cubical body is totally submerged in the submerged condition. So this body is displacing how much water? This much water only, right? So the force of buoyancy will be passing through the center of gravity of this particular fluid. However, if we take a half submerged body, say like this, then the liquid displaced by the body will be this, only this. Then force of buoyancy will be acting not on the total center of gravity of the fluid, but the center of gravity of the fluid displaced. So this is the center of gravity of the body, this is the center of gravity of the fluid displaced, and it will act like this on this particular point. If I mark this from a different ink, this point. So we have to be very cautious while applying the buoyant force on the center of gravity, not on the center of gravity of the body, but on the center of gravity of the fluid displaced. Before moving to any question, we should know a popular theory, that is the Archimedes principle. So let us see what Archimedes has said about the buoyancy, particularly related to body. So he has said about a body which is submerged and immersed. So it can be fully or partially, as in these two cases. This is fully submerged and this is partially submerged. In a static fluid, he is saying static fluid, a net hydrostatic force acts on the body in the vertically upward direction. This force is known as upthrust or buoyant force, and the amount of this force is equal to the weight of the body. So it is saying the same thing that we have studied right now. So now we will move to the questions, how to deal with the problems of buoyancy. And so let us start our question number 1. This is a simple question. So I am going to teach you how to approach the problem step by step. Every word is important. So first and foremost thing, they have asked you to calculate the volume of water displaced. So volume they have asked you to calculate, and the position of center of buoyancy. So my two questions are clear. Of a wooden block of width, so let us say that this is the width. This is 2.5 meter. Depth is 1.5 meter, and which floats horizontally. This floats part is important. So floats horizontally, and density of this wooden block is how much? Density of block is how much? 650 kg per meter cube, and its length is how much? Length, if I say this one is 6 meter. So why I am saying that this float portion is important? So if I draw it like this, then it is called as floating. If I draw it somewhere inside the fluid, then it is called as submerged. So that's why he has asked you to calculate the volume of the water displaced. Otherwise, if had it been the water block inside the fluid, the volume of the water is displaced would have been the volume of this block only. So let us first see. We know that this part is 2.5 meters, and this whole part is how much? This is 1.5 meters, and inside it is going as 6 meters. if I see that the volume displaced by this fluid is, by this block is this much, right, this much. So this part is in 3D, so don't confuse, this part is in 3D. So if I just calculate this depth h, then I can calculate the volume of the fluid, right, displaced by the block. We know that the center of gravity of the block is somewhere in the middle, center of gravity of the block, and it is acted upon by what? Weight of the block, right, weight of the block. And from the buoyancy part, we have considered that the center of buoyancy will be somewhere in the middle, because center of buoyancy is what? Center of buoyancy is the center of gravity of the fluid displaced. So this is the fluid displaced, this red portion is the fluid displaced, and this center of buoyancy, CB, if I write, then this is acted upon by what? Is acted upon by buoyant force. Since the body is floating, since the body is floating, right, if it's floating, then the total summation of all the forces in the vertical directions will be equal to 0, right? So if I consider that upward part is positive, then Fp minus W will be equal to 0. Force of buoyancy is what? Force of buoyancy is density of the liquid into G into volume displaced by the fluid. Displaced by what? Displaced fluid or liquid, minus what will be the weight of the block. So if I say in the side, weight is what? Gamma into G, right? Gamma into volume of the block, which will be density of the block into G into volume of the block. So density of the block we already know, we'll directly put it in the G, we know. And volume of the block will be how much? Volume of the block will be length into breadth into height. Length is how much? 6, breadth is how much? 2.5, and height is how much? 1.5. So we'll use this. Let us put W in that direction. Let us see if we know the liquid in which the block is immersed. See, he has said water, volume of water displaced. So we know that the liquid is water, and we know that the density of water is 100 into 9.81, and the volume of the liquid displaced, you can see that the volume of the liquid displaced is, height is h, width is 2.5, and length is 6. So if we calculate first we have to calculate the h, right? So let us calculate. They have asked us to calculate the volume of liquid displaced. So displaced liquid we will first find out. So GP, I'm just putting the numbers. So volume of the liquid comes out to be, after finally solving, it comes out to be 14.625. But the volume was not only the question, they have also asked us the position of center of buoyancy. So position of center of buoyancy is half of this h2. This h means h2, it's somewhere here, right? So this, if this was h, this is h by 2. So we just have to calculate h. So what is h? What is this volume of liquid displaced? It is this height h, this width 2.5, and this length. So height into width into length will be equal to 14.625 meter cube. So height will come out to be how much? Height will come out to be 0.975 meters, and as a result we can directly say that center of buoyancy will be h by 2, which is 0.4875 meters from bottom. You can say bottom. Okay, so this concludes this question. Let us do one more question on this part. So question number 2. Question number 2 is, find the density of the metallic body which floats they have asked us to calculate the density of a metallic body. So we know that some body we need to find density, okay, which floats. Again, it is floating at the interface of mercury and water, such that 40% of its volume is submerged in mercury and 60% is submerged in water. So first of all, it is floating. It says it is floating, but it is at the interface. Say like this is the interface between mercury. So if I ask you whether this will be mercury or this will be mercury, so you can easily say that since the specific gravity of mercury is 13.6, mercury will be in the below portion. So if this is my body and it has a volume of V, it can easily be said that okay, this is water, this is water, this is mercury. Mercury will be below because mercury is heavier than water. And other thing that has been said, that is water 40% is submerged in mercury, means this volume is 40% of what? The total volume of the body. Total volume of the body is suppose V, so it's 0.4 V. And in the water they have said that it is 60%. So 60% of what? Total volume, which is 0.6 V. Okay. Now we need to find the density of the body. So again, if it's floating, the total vertical force on the body will be equal to 0. So we need to first of all draw the free body diagram. So let us say that okay, if it's a solid body, it will be acted upon by its weight, which is m into g, right, which is rho of body into g into rho of body into volume, since mass is equal to volume into density. And since it is the weight of the body, so it will be the density of the body here, rho v and g. And as we know that, as we have recently studied, that buoyancy acts on the center of buoyancy. Say we are now concerned only on the vertical force. So this water will be providing one center of one buoyant force, and this mercury will be providing one other buoyant force. Since we are considering only the forces in the vertical directions, and this body is floating, which means that the total force in the vertical direction has been neutralized, means all the forces in the downward direction has been neutralized by all the forces in the upward direction. Which means what? If I consider this direction as positive, means Fb1 plus Fb2 will neutralize what? The weight of the body, right? Now what is Fb1? Fb1 is the force of buoyancy due to the liquid displaced by the body in water. So rho of water into g, and what will be the volume displaced is 0.6 V, and rho of mercury B2 will be what? Rho of mercury into g into 0.4 of V, and weight will be rho of body, which we want to calculate. They have asked us this particular density in the question, and volume of the body, we know it's V and G. So we just need to cancel out the common terms, G V V G V. Okay, so what is remaining? This is density of the body. Density of water is, we know that it's 1000 into 0.6 plus mercury specific gravity. They have given the specific gravity into density of water. This will give you the density of mercury and 0.4, and here density of body. So the density of body will finally come out to be 6040 kg per meter cube, and this concludes our question. This is the final answer. This whole after studying this whole concept, can we now say that which body will float on the water and which will remain submerged and which will drown? So let us take an example. Okay, say like submergence case. Say case 1, submergence case. Can we say that whether a body will be submerged? Say like this. Okay, this body is inside the water, so it is submerged, means it is acted upon. So if we know that a body is always acted upon by its weight, right? And once it's inside a fluid में जैसे ही चला गया उसके ऊपर क्या एक फोर्स आ जाता है, point force, right? So now it is submerged, it is not going up, neither it is going down. Okay, so which means what? Means force of buoyancy is balancing what? Weight. What is force of buoyancy? Force of buoyancy is liquid's density into G into volume of liquid displaced liquid, right? And weight is what? Mass is what? Again density into volume, and G, this is M, and we know that weight is mg, right? So this should not create any confusion whatsoever. So here we know that in this particular example, in the case of submergence, the volume of liquid displaced is what? Is the actual volume of the body, which means that these two are same, which means that if this will come out. So if I say that okay, if the liquid volume in which my body is there and the volume of the body and the density of the liquid and the density of the body are equal, then the body will remain submerged. It will not go anywhere, it will just stay put. If I see the second case will be like floating body. So we know that this is acted upon by what? Weight. A body is always acted upon by its weight, and the liquid displaced by this body is this. There will be a buoyant center or the center of buoyancy, and through the center of buoyancy what force will be acting? Buoyant force. Since this body is floating, means that what? This buoyant force is being balanced by the weight, and we know that buoyant force is what? Liquid's density, whichever liquid that was displaced, into G into volume displaced equal to what? Again volume of the body into G, density of the body into G into volume, and G is cancelling out. We see that another thing, the displaced liquid. Here the volume of the displaced liquid is what? Is less than the volume of the body, right? Which means what? The liquid volume of the body is less than volume of the liquid. Okay, so from this we have made a conclusion that if the liquid density is greater than the density of the body, then it will float. From the previous scenario we said that if the liquid density is equal to the body's density, then it will be submerged. It will be submerged, but it will not go down, neither it will go up. Okay. Another third case will be if the body's density is more than the liquid density, then the body will what? Body will drown slowly, right? That is why when you go for swimming And people say that okay, if you keep your if you lie inside the water, you will float, which means what? The density of human body is less than the density of water. That's why we float. That's why we float in the water. So this concludes the buoyancy part. In the next lecture, we'll be studying about the stability of the submerged as well as the floating bodies, and after this will which and then we'll move forward to metacentric height and metacenter. So this is the end of the lecture. Thank you.